The 2005 National Electrical Code, or NEC, represents a significant iteration in electrical safety standards. Understanding the proposals, acceptances, rejections, and public comment surrounding this edition is crucial for electrical professionals. The NEC is updated on a 3-year cycle to address emerging technologies, new safety concerns, and lessons learned from the field. The process of developing the NEC involves a committee of experts who review proposed changes, known as reports on proposals, or ROPs. These proposals can originate from a variety of sources, including electrical engineers, contractors, inspectors, manufacturers, and other interested parties. The ROP are published for public review and comment, allowing stakeholders to weigh in on the proposed changes. After the public comment period, the NEC committee reviews the comments and makes decisions on whether to accept, reject, or modify the proposed changes. The results of these decisions are published in the Reports on Comments, or ROCs. These reports provide valuable insight into the rationale behind the code changes. Accessing and understanding these documents is essential for anyone working in the electrical field. By reviewing the ROP and ROC, electricians, engineers, and inspectors can stay up to date on the latest code requirements and ensure that their work complies with the highest safety standards. Some key areas of focus in the 2005 NEC likely included grounding and bonding, overcurrent protection, wiring methods, and equipment installation. For example, changes related to grounding and bonding might have addressed issues such as the use of ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or FSIs, in specific locations. Modifications to overcurrent protection requirements could have involved changes to the sizing of circuit breakers and fuses, as well as the application of selective coordination principles. Revisions to wiring methods might have addressed the use of new types of cables and raceways, as well as the installation of wiring in hazardous locations. And updates to equipment installation requirements could have covered a wide range of topics such as the installation of transformers, generators, and other electrical equipment. Specific examples of code changes from the 2005 NEC would require a detailed review of the ROP and ROC for that edition. However, it is possible to illustrate the types of changes that are typically considered. For instance, a proposal might have been submitted to require the use of tamper-resistant receptacles in dwelling units to protect children from electrical shock. This proposal would have been evaluated by the NEC committee based on factors such as the availability of tamper-resistant receptacles, the cost of installation, and the potential safety benefits. Public comments would have been solicited from interested parties, such as manufacturers, contractors, and consumer groups. Based on the evidence presented, the NEC committee would have made a decision on whether to accept, reject, or modify the proposal. Another example could involve a proposal to change the requirements for the installation of surge protective devices, or SPDs. This proposal might have been prompted by concerns about the increasing use of electronic equipment and the potential for damage from voltage surges. The NEC committee would have evaluated the proposal based on factors such as the effectiveness of SPD, the cost of installation, and the potential for reducing equipment damage. Public comments would have been solicited from interested parties, such as manufacturers, engineers, and insurance companies. Based on the evidence presented, the NEC committee would have made a decision on whether to accept, reject, or modify the proposal. Understanding the rationale behind these code changes is crucial for ensuring compliance and promoting electrical safety. By reviewing the ROP and ROC, electrical professionals can gain a deeper understanding of the factors that influence the NEC committee's decisions. This knowledge can help them to make informed decisions about the design, installation, and maintenance of electrical systems. The NEC is a living document that is constantly evolving to meet the changing needs of the electrical industry. By staying up to date on the latest code requirements, electrical professionals can help to ensure that electrical systems are safe, reliable, and efficient. The NEC is not just a set of rules, it is a comprehensive guide to electrical safety that is based on years of experience and research. By following the NEC, electrical professionals can help to protect people and property from the hazards of electricity. Grounding and bonding are critical aspects of electrical safety, serving to minimize the risk of electric shock and fire. The NEC provides detailed requirements for grounding and bonding electrical systems and equipment, ensuring a low impedance path for fault current to flow back to the source. This low impedance path facilitates the rapid operation of overcurrent protective devices, such as circuit breakers and fuses, which interrupt the flow of current in the event of a fault. The NEC distinguishes between grounding and bonding, each serving a distinct purpose. Grounding refers to connecting the electrical system to the earth, providing a reference point for voltage and helping to stabilize the system. Bonding, on the other hand, refers to connecting all metal parts of the electrical system together, creating a continuous electrical path. This continuous path ensures that all metal parts are at the same potential, minimizing the risk of electric shock. Changes to grounding and bonding requirements in the NEC often reflect advancements in technology and a better understanding of electrical safety principles. For example, the NEC may be updated to address new types of grounding electrodes or to clarify the requirements for bonding different types of metal raceways. Overcurrent protection is another essential aspect of electrical safety, designed to protect electrical systems and equipment from damage caused by excessive current. Overcurrent can result from various factors, such as short circuits, ground faults, and overloads. The NEC specifies the types and sizes of overcurrent protective devices, such as circuit breakers and fuses, that must be used in different electrical circuits. Circuit breakers are automatic switches that interrupt the flow of current when it exceeds a predetermined level. Fuses are sacrificial devices that melt and break the circuit when the current exceeds their rating. The NEC also addresses the concept of selective coordination, which involves coordinating the operation of multiple overcurrent protective devices in a system. Selective coordination ensures that only the overcurrent protective device closest to the fault will trip, minimizing the disruption to the rest of the system. Changes to overcurrent protection requirements in the NEC often reflect advancements in overcurrent protective device technology and a better understanding of overcurrent phenomena. For example, the NEC may be updated to address new types of circuit breakers or to clarify the requirements for selective coordination in specific applications. Wiring methods encompass the various ways in which electrical conductors are installed and protected. The NEC specifies the types of wiring methods that are permitted for different applications, taking into account factors such as the environment, the voltage, and the current. Common wiring methods include rigid metal conduit, electrical metallic tubing, non-metallic conduit, cable trays, and various types of cables. Each wiring method has its own advantages and disadvantages, and the NEC specifies the conditions under which each method is permitted. For example, rigid metal conduit is often used in locations where physical protection is required, while non-metallic conduit is often used in corrosive environments. Changes to wiring method requirements in the NEC often reflect advancements in wiring material technology and a better understanding of wiring installation practices. For example, the NEC may be updated to address new types of cables or to clarify the requirements for installing wiring in hazardous locations. Equipment installation requirements cover a wide range of electrical equipment, including transformers, generators, motors, and appliances. The NEC specifies the installation requirements for each type of equipment, taking into account factors such as the voltage, the current, the environment, and the intended use. These requirements are designed to ensure that the equipment is installed safely and correctly, and that it will operate reliably. For example, the NEC specifies the clearances that must be maintained around transformers to prevent overheating, and the grounding requirements for generators to prevent electric shock. Changes to equipment installation requirements in the NEC often reflect advancements in equipment technology and a better understanding of equipment safety. For example, the NEC may be updated to address new types of transformers or to clarify the requirements for installing equipment in damp or wet locations. Staying informed about the changes and interpretations of the National Electrical Code is paramount for all electrical professionals. The NEC serves as the cornerstone of electrical safety, providing the standards and guidelines necessary to protect people and property from electrical hazards. The 2005 NEC, like all editions, contains specific articles and sections that address various aspects of electrical installations. To fully understand the changes, acceptance, rejections, and comments surrounding the 2005 NEC, it's essential to delve into the specific articles that were revised or added. For instance, Article 250 covers grounding and bonding. Significant changes in this article could affect how electrical systems are grounded to ensure safety and minimize the risk of electrical shock. Article 300 addresses wiring methods, encompassing requirements for installing and protecting electrical conductors. Revisions in this article may introduce new wiring methods or modify existing ones to enhance safety and performance. Article 400 pertains to flexible cords and cables, outlining the permitted uses and installation requirements for these types of wiring. Changes in this article could affect the selection and application of flexible cords and cables in various environments. Article 408 focuses on switchboards and panel boards, providing requirements for their construction, installation, and protection. Revisions in this article may address safety features, such as arc flash protection, and performance standards for these critical components of electrical systems. Article 500 and subsequent articles cover hazardous locations, addressing the specific requirements for electrical installations in areas where flammable gases, vapors, or dust may be present. Changes in these articles are crucial for ensuring the safety of workers and equipment in hazardous environments. Understanding the specific changes within these articles, as well as others relevant to your work, is essential for complying with the 2005 NEC and ensuring the safety of electrical installations. The process of reviewing the ROP and RRC for the 2005 NEC can seem daunting, but it is a valuable exercise for electrical professionals. By understanding the proposals that were submitted, the comments that were received, and the decisions that were made, you can gain a deeper appreciation for the rationale behind the code requirements. Additionally, reviewing these documents can help you to identify potential areas of confusion or ambiguity in the code, and to develop strategies for addressing these issues. The NEC is a dynamic document that is constantly evolving to meet the changing needs of the electrical industry. By staying informed about the latest code requirements, you can help to ensure that electrical systems are safe, reliable, and efficient.